Hello everyone, I welcome you all to this class. This is mathematics class, and today we'll be studying how to find the derivative of exponential functions. We did that in our previous class, the introduction, using one particular example. But this class we'll be solving the second example on this topic. And in this second example, this second example is not exactly as the first example we considered, and I will tell you why. Remember that if the exponential function we considered at the first example has to do with exponential function of the Euler number, and I told you that if you have that y is equals to exponential u of x, then the derivative of y with respect to x is derivative of u with respect to x, the u dx multiplied by the whole of the exponential function exponential u of x. But in this very question they gave us that y is equals to 5 raised to power x. It's still exponential function, but it's not exponential function of the Euler number e. So for us to find the derivative of this, I'm going to transform this to the exponential function of the Euler number e by simply taking the log of both sides. So we are going to start by solution, and we have that y is equal to 5 raised to power x. We take the log of both sides, the natural logarithm, which is the lane of both sides. Take the lane of here. I have lane y is equals to lane 5 raised to power x. So I took the lane of both sides. Why am I taking the lane of both sides? Because the lane, which is the natural log, will bring down this what? Exponent, will bring x down, right? So by so doing, this implies that lane of y is equals to, I have lane y here, right? Then I have equality sign here. Then by the property of lane or log, this x here, the exponent, can be brought down here, so that this x now will be brought down here. I have x lane of what? 5, right? I have x lane of 5. So what I've written down here is that we should take the exponential of both sides. Remember, what we have here is lane y equals x lane 5. Why am I taking the exponential of both sides? I want to make y the subject, because once I put exponential, that's the Euler number here. If I put it here, then the exponential will cancel this lane. Then I'm going to have y. So I have to take the exponential of both sides. So by so doing, I took the exponential of both sides. I took the exponential of here, I took the exponential of here. So that we can now make y the solution of the formula, and by so doing we have transformed this function to this exponential function y equals 5 raised to power x, to the exponential function of the Euler number. So that by so doing, exponential and lane will get cancelled. You will now have y is equals to exponential x lane of what? 5. So this is what we have. So that we have transformed this to the what? Exponential function of the Euler number, as we have it in this definition. So that the derivative of y with respect to x, then the y dx will be given is equals to du dx multiplied by what? Exponential u of what? X. By formula, right? By the formula I have here. What is u? U is what is on the exponential. What is on exponential is what? X lane of what? 5. So I'm going to differentiate this x lane of 5 with respect to x. That's what they say. Differentiate what? Differentiate u with respect to what? X. The u the x, right? So if I differentiate x lane of 5 with respect to x, I'm going to get what? I'm going to get a lane of 5. So I have lane of what? 5. You know that if you differentiate 2x is what? 2, right? If you differentiate 2x, you get 2. So if I differentiate x lane of 5, I'm going to get lane of what? 5. That's the derivative of u with respect to x. Then multiply by the whole of exponential u of x. That's the whole of exponential function you have. That's exponential x lane of 5. So this will be equal to lane of 5 multiplied by what? This quantity is y. So I will replace this whole quantity with what? Y. Right? So if I replace this whole quantity with y, so this will be equal to y ln of y ln of 5 as the result. So y ln of 5 is the result of the derivative of this very exponential function. So thank you so much for being part of this class. See you in our upcoming class. In our upcoming class, we'll be treating implicit differentiation. So see you in our upcoming class. Bye.